In this video, we're going to be looking at some important ideas like the time value of money, financial math terminology, and simple interest. This is the first lesson of Unit 7, Financial Applications, as part of my Grade 11 Functions course. If you want me to teach you this entire course, visit my website, tutor.ca, and enroll in the Second Teacher program, which includes video lessons, private tutoring, notes, and practice problems for every section in Grade 11 Functions. I hope you enjoy the video. Hello everyone, I hope you're doing well. Welcome to lesson 37 in the Second Teacher Program's course on Grade 11 Functions. Here we're looking at similar content to section 7.1 from our textbook, which is simple interest. So this is the first lesson of our financial math unit, which is the final unit of this course. So you've made it quite a way through. And so we've just got one more unit to do. In fact, this is a pretty simple unit. And the first section is called simple interest, so it's pretty simple all around. And so in this unit, we're going to be looking at some concepts that relate to financial math. In fact, we're going to spend a good amount of the time just talking about just different ideas in financial math that you need to think about before you can start learning this kind of stuff. And then at the end, we're going to start talking about simple interest, which is a certain way to calculate interest, but all of this will hopefully make sense by the end of the lesson. And then we have some examples. So in this unit, we're going to be using a lot of different ideas that we've talked about throughout this course, like functions and exponentials and sequences. These will all kind of come into play in this unit, so it's going to be a pretty interesting one. It's nice to see how all this math can be applied to something in real life, and this is something that you do for a long time, right? Dealing with money. So in this chapter, I'm going to essentially make two assumptions that of things you already know, right? So these are my assumptions, things that I don't really have to go too much in detail. So you know what money is, and you know what a loan is. Okay, so I'm going to use the two words money and loan as if you already know them, because I think that's a pretty reasonable thing to start with. But I don't expect you to know anything else really about how money works, right? And so that's going to bring us into the first thing that I want to talk about today, which is the concept of interest. Okay, and so I'm going to kind of illustrate this idea with two smaller examples, right? So the idea of interest is that if you sign a contract with someone, like let's say you're here, this is you, right? And you meet with some random person, right? And you decide that you have $500, right, to spare, or that you don't particularly need at the moment, right? And this person needs $500, so you sign some sort of document that says, okay, you will give this person $500 for 2 years, right? So you would loan this person $500 for 2 years, right? And the amount of money and the amount of time doesn't particularly matter, but you loan someone an amount of money for a certain amount of time, right? Then at the end of the transaction, you've agreed in this contract that at the end of the transaction, this person will pay you back $500, right? This person will pay back $500 after 2 years is up, and a little bit extra, right? Because you've gone through the trouble of going through this process where you're giving someone your money for 2 years, right? Some amount of your money. So they're going to be giving you the $500 back plus some extra, right? Because you went through some trouble there. That little extra is called interest. Okay, so there's your first example of how interest kind of comes into play, right? And then there's another way interest can come up. And so let's say you don't have $500. In fact, you don't have that much money, and so you want to buy a car, right? So you're going to go to the dealership, and you pick out your car, whatever. You have some certain amount of money, but you can't afford to buy the entire car in one payment, right? Most people can't do that. So you take out a loan from the bank, right? Let's say the car is $30,000, and so the bank gives you $30,000 to pay for the car. So by the end of, let me put this here, $30,000 car. By the end of the however many years you've agreed with the bank to borrow this $30,000 from, you will certainly pay back that $30,000, but the bank will also expect a little bit extra from you, right? A little bit extra. So that little bit extra, right, is called interest, right? And in this example here, right, you earned interest, right? You earned interest here. Here you paid interest, right? So interest is the idea that if money is spending an amount of time in, some other people's pockets, right, through a loan, then interest will be either earned or paid by the people in the loan. In general, right, the borrower pays the interest. Okay, so here, this is the borrower, right? That person paid the little extra. here you're the borrower, right? And you paid a little extra back to the bank, right? So the borrower pays interest. So there's a whole bunch of questions you can ask now about interest, right? You can ask, how should interest be calculated, right? How much should that extra be? Should the interest be based off of the initial amount of money, right? Should it be broken into many parts, right? And what if you make monthly payments, right? How does that affect the interest? So all of these questions, all these 4 questions here, is pretty much the whole point of this unit, is to understand how interest is calculated, the different ways we do that, and how we can sort of break it into parts, and what happens when we make monthly payments. So all of these questions will be answered in this unit. So let's take a quick look at the general outline of the unit before we actually get going, looking at different looking at simple interest, really. So this is generally what's going to happen here. So we are starting, obviously, this lesson with 7.1, simple interest. So this is the simplest kind of interest that you can calculate. It's pretty basic. In fact, it's not used very much in the real world, but it's a good starting point. Then we have compound interest, which is very, very common. This is how most interest payments are calculated. And then we have present value. In the present value section, we're going to be looking at how the money you have in the future, how much is it worth today, right? And questions like that. So it's a little bit of a theory in that section. And then annuities. Annuities is like regular payments, right? This is so we're going to start dealing with regular payments here. How do you deal with, how do you calculate interest when you're making regular payments? And then, same idea. How much is future regular payments? How much are they worth today, right? So regular payments, but at the present value. This will make sense as we go through the unit, but there's your little outline. Okay, so let's begin then with the next, main concept that we have to kind of get down here, which is called the time value of money. Okay, this is pretty much the reason that we have all of these calculations that we should do, because money really has a time value, and that's because of interest. So this is really the biggest concept you need to understand in this section is this right here. So what this means is that the value of some amount of money changes with time. I'm going to write that here. The value of some amount of money changes with time. So I'm going to explain this with some examples, right? If today, let's say this, I'm going to draw a little diagram here. So let's say this is today, and this is 2 years from now, 2 years later. So if today, right, you, which let's just say, person one, let's just say person one has $500, right? And let's say in 2 years from now, another person has $500, different person also has $500, right? You do not have the same buying power, right? Or purchasing power in these situations, right? And the reason for that is because you today could put your $500 into some sort of loan, right? You could loan that $500 to someone. Let's say this is the loan that is being put into for these 2 years, right? Let's say, maybe I'll make that box a little bit better. Right? Say this is the loan is being put into, right? So this is a loan. In particular, it's a loan which collects interest, right? And after the 2 years, right, you will be left with more than $500, right? Oops, more than 500. Put the head on the wrong side. You'll be left with, let's just say randomly, this is $525, right? Let's say this loan right here, you collected some sort of interest, right? Because you put in a loan, and now out of it, you get your $500 back plus a little extra, and that little extra ended up being $25. Don't worry about why 25. Let's just say that's a random number. That's what it was, right? We're going to look at how to calculate these things. Right? So as you can see, really, if you compare the amounts of money that people have, right, you have to compare it at the same time. Right? It doesn't make sense to say that I have $500 today and someone else has $500 2 years from now, and so we have the same amount of money, right? We have the same buying power, right? Sure, we have the same number, like the actual number is the same, but the buying power, as in how much you can buy, is different, right? Because if you compare them right in the same time, right, at the exact same time, 2 years later and 2 years later, you can see it's pretty clear that the person one has more money, and this is because money has a time value, right? So as time progresses, the value of your money can change, right? There's lots of ways this can happen. There's lots of other ideas that if you choose to spend more time studying economics, there's lots of ways that the value of money changes with time, but interest is one of the ways that the value of money changes with time. And that's what we're going to be studying in this course, is how interest affects the time value of money. Okay. So that is essentially the main idea here about why we're interested in doing these calculations, is because we want to see, we want to compare how much money different projects are worth, or maybe how much money different people have, right? And so the important thing is that, so when comparing the value of two amounts of money, they need to be compared at the same time, right? Compared at the same time. Because you see here, like we have $500 today is not the same thing as having $500 2 years from now, right? Those are not the same things. So, and this is because, money can collect interest, right? And so, being 2 years in the past is really an advantage compared to this guy, right? Because then you can collect interest for 2 years before you're at this point. Okay, so that's the main idea about the time value of money. So the next section I want to go through is just some terminology. So I'm going to be using this example a lot to explain the different pieces of the terminology that's commonly used in this unit, right? So focus on this idea that's happening in red here, right? You have $500, you put in a loan, you have $525 at the end. Okay, so the first piece of terminology is called the principal. Okay, so the principal. Okay, the principal is the initial amount of money at the beginning of the transaction or loan. Let's just call it a loan at the beginning of the loan, right? So let's say here that's the main idea. So when I say principal, right, you can just think of it as like the initial amount of money, right? That's a good way to think about it. Okay. Okay. So then we have this. So I'll put that there nice in capitals. So in the example up here, that would be $500, right? So from our example that we did before, that would be the amount $500, $500 from right here, right? That $500 is the initial amount of money. Okay. Future value, pretty unsurprisingly, this one's pretty self-explanatory. The future value is the value of the principal after time has passed. Okay, so the way I word this is important. There's the value of the principal. The principal is how much money you put in. Its value after time has passed. Because remember, money has time value. So the principal is some initial amount of money. After some time has passed, its future value is that new value there. Okay, which will be probably greater, right? If it's just based off interest, it will be greater. Okay, so that's the future value. Oh, and then for comparing it to our example, that would be $525, right? Oops, $525. Right, there we go. Okay, so then we have our next piece of terminology, which is the interest paid. So the interest, okay, earned or paid, okay, which kind of is the whole term that I'm kind of going for here. So it is the change in the value of the principal. Okay, so in our particular example, that would be $25. The value of the principal changed by $25, so the interest earned is $25. Okay, so that's what I mean when I say the interest earned. Okay, now the next one doesn't particularly actually have a comparison to the example there, right? So then we have the annual rate, okay, or the annual interest rate, right? Or it's also called the rate per annum, okay? And so these are all just the same words to describe, different words to describe the same thing. And what that thing is essentially, so the annual rate is the number you base the calculation of the interest off of, right? So I'll do an example of that in just 1 second here, just to give you an idea of what exactly that means. But pretty much those are the 4 definitions that are kind of always there when you're talking about financial math. And then there are other definitions, there are other important words, but you can learn about those when we actually get to that part of financial math. So before we start talking about simple interest, let me just explain a little bit more about what I mean here by the annual interest rate. So this is a number that's either given by the banks, so I'll say it's either given by the banks. If you are, this is if you're taking a loan from a bank. So I'll say bank loan. Or if you are putting money in a savings account, right? So money in a savings account. So the other way that you can get an interest rate is it can also just be privately decided by the people making the loan, right? So privately decided upon, right? But it's usually something that's given in the question. In fact, most of the, like 90% of the time, the interest rate is just something that's given in the question, and it's something you base your interest calculations off of. So when I say that, the interest is, let's say 5%, right, per year, okay, and the annual interest rate is always given per year, right? Even when we make calculations that are not in a nice yearly basis, they're calculated, the interest rate is given per year. What I'm essentially mean is that, well, this is kind of getting into the example of simple interest, but, the most simple way we could put this is that 5% per year means that, if I borrow $500, right, now, $500 is just a random amount, doesn't really matter. 1 year from now, right, what I'm going to owe is $500 plus 5% of $500, right? And that's what I mean when I say the interest rate is 5%. And then that would carry on for if I said like the interest rate was 12% or something like that. Then you would owe the principal, right? This is the principal, right? So I'll say that there is the P for principal. And then you owe the interest rate percent of the principal, right? So 5% of 500 or 12% of 500, or it doesn't matter, whatever the principal is. Okay. So this is really getting into the next kind of topic here, which is simple interest, which is pretty much exactly the process that I just described there. It's kind of like the most natural way that you would think about using percentages to calculate interest, right? It'd be some percent of the initial amount you borrowed, right? So simple interest, I'm going to write some important points here, right? So this is the first type of interest we learn about. Right? It is not used in real life often. Okay? And you'll see why you'll see why in the next section when we start talking about the other kind of interest. But it's not used often in real life. But it's a pretty natural way to think about collecting interest. Okay, because it's literally just you take some sort of slice of the original amount per year, right? So if I just carry on this example for 1 second here, right? If it's 5% per year, and then let's say I didn't pay back the amount here. I paid back the amount 2 years later, right? Then what I would owe is I would owe $500. Of course, I'd owe the original amount back plus 10% of 500, right? Because it's 5% per year. So 2 years, it's going to be 10%. I owe 10% of 500. Right? And this would keep going if I waited longer and longer and longer to pay back the loan. Or, this is probably agreed upon how long it would take before I do that. So this whole example up here is really what simple interest is, but we'll put it into some sort of formulas here to help us out a little bit. But if you understand this, that's pretty good, right? Okay. So to calculate the future value of some principal, so using simple interest to calculate the future value, which I'm just going to call FV, right, of some principal, right, which I'm going to call capital P. What we do is we break that into the principal plus some interest, which I'll call I. So all I'm saying here is that if I want to figure out, if I make a loan or I put some money in a bank account or something like that collects interest, then what I want to do is I want to know the future value of that money. Right? So it's going to be equal to the principal plus some interest that I've collected or spent, right? Okay, so future value, right? Principal plus interest. But we've kind of pushed the problem a little bit further down the line because now you still have to ask, how do we calculate the interest, right? So let me just label everything here, right? So this is future value, principal, and interest. So future value, principal, right, and interest. Okay. Now, how exactly do we calculate this? Now, using simple interest, right, the formula, what this is going to be, the interest is the principal times the interest rate that they gave you, right, times the number of years, right? And that's essentially, this right here is the main formula for a simple interest, what I've just kind of highlighted here. That's essentially the main idea, is that the interest is equal to the principal times the annual rate they gave you, annual rate, times the number of years. So time in years. Very importantly, it's in years because your annual rate is always in years, right? So comparing this to our example here, what we talked about right here, really I'm doing the same thing, right? I'm just kind of now putting it into a formula, right? I have said that my future value, this is the future value, right, is equal to the principal. So let me get rid of that. This is the principal, right, plus some interest, right? And that is the interest. That is the interest, right? Once again, that's again the principal plus some interest. Principal plus some interest. And now the way I calculated that interest is by multiplying the principal times the rate times the number of years. So that's what's happening here, right? 5% of 500 is 5% times 500. And here, this is 10% times 500. But you can think of that as, 500 times 5% times 2, right? Because it's 2 times 5% is 10%. So that is the principal times the rate times the number of time. The number of years, I mean, sorry. And similarly here, this is 500 times 5% times 1, which is, again, the principal times the annual rate times the number of years that have passed. So what I'm doing is I'm just calculating the interest that I'm going to pay based on the principal and the annual rate and the amount of time that has passed. Okay. So the main formula, the formula to really remember, is that using simple interest, just using simple interest, the future value of some principal is equal to the principal plus PRT, right? That's essentially this formula, but I just replaced I with PRT. And these, essentially the two blue boxes, well, you'll see the other blue box in a second. These are the two things to really remember here in what's going on here, right? So that is your interest I, right? PRT, and then that is, of course, your principal, and that's your future value. Everything else is labeled here. Okay, so using this now, we can go ahead and do a couple examples to try to, really understand what's going on here. So I'm actually going to do another example here first, not one from my notes. So if you put, let's say, I don't know, $1,000, well, let's make it $1,200 in a bank account. Oops. Oh, let's actually say a savings account, which pays, let's just say, 4% simple interest. Okay. How much will be in the account after 4 years? Okay. So what we're saying here, what you got to understand first is, who's the borrower, who's the lender here, just to make sure, it says pays 4%, but who's paying the interest, right? So what you've done here essentially is you've let the bank borrow $1,200 from you, right? So you have $1,200. You are putting that inside the bank account, which now has $1,200, right? This is now. And now 4 years later, you want to look inside that same bank account and you want to take some money out and you want to know how much is going to be in that bank account there, right? So the borrower is the bank, right? Bank is the borrower. Oops. Bank is the borrower. And so the bank will be paying you money. How much money? Well, this is how we calculate it. It pays 4% simple interest, right? Anytime you're given a percentage like this, I know it doesn't say per year, right? But anytime you're given a percentage like this, it is implied, it's written without writing it, that it means per year. So now that we have this information, we can actually calculate what's going on in this thing. We can calculate the future value, the value of this $1,200 after 4 years has passed. Because remember, this money here has a time value. So as time passes, it will be worth more from the interest. So we're going to use this formula right here. So to calculate this amount right there, it's going to be, FV, right? But I'll leave it blank just for now because I want to put the value in there. And so FV, the future value, is equal to the principal, $1,200, plus the principal, $1,200, times the annual rate, 4%, right? Times the amount of years that have passed, 4 years. Right? And again, this is using simple interest. There are other ways to calculate this. If they said compound interest here, right, which is the thing we're going to study in the next section, then you can't use this formula, right? This formula is just for simple interest. But since this section is on simple interest, we can definitely use this. And so now you just plug that into a calculator, right? That's just some number that we can calculate there. It's 1,200 plus 1,200 times, and now importantly, you can't just type in 4, right? It's not 4 times 4 at the end here. This is 1,200 plus 1,200 times 0.04, right, times 4, right? Some calculators have an actual percentage button, but you don't have to do that. You can just type in 0.04, which is 1,392. So after 4 years, it's $1,392, right? So the principal is $1,200. The future value is $1,392. And we might ask now, what's the interest? What's the interest gain? Maybe this is part A. Maybe part B would be, what's the interest gained? What is the interest gained by this gain? Let's just say that. Well, all you do here is you want to figure out, well, what's the difference here? How much did it go up? Right? How much did this amount go up? And so you can just do that. You can calculate the interest gained by just doing the future value minus the principal. Right? 1,392 minus 1,200, right, is $192, right? So after 4 years, you've gained $192 from simple interest in this account. Okay. So banks in real life don't give anywhere near 4% simple interest. In fact, they don't calculate it with simple interest. They calculate it with compound interest. So I'll talk about the kind of real world numbers in the next lesson because that's how they actually calculate it. But percentages are usually, less than 1% of interest that they give. So it's nothing nearly this big. But just to, for numbers to be big here, we'll do it with that. Okay, so let's take a look at another example that I have written here. So it's going to be, somewhat similar. What is the future value of some amount of money? I don't know, $1,560, right? If it is, and I'm going to put in quotes here, invested at, I don't know, let's just say 0.5%. Let's do 0.5%, right? Simple interest for, let's say, 18 months. Okay, let's say that's how long it was. That's how much it is there. Okay, so this is another simple interest question. And there's a couple little technicalities to it here that's going to be making it a little bit more complicated. So, put example, and there's our first example there. So I have to define what invested means before we begin this example. And so invested is really just kind of a word that can mean a lot of things. It just means that you are taking this amount of money, right? And you are putting it into some other person's pocket, right? That could be a bank, that could be a company that you're giving this money to. But all you know is that you're giving this much money and you can expect this much interest to be gained off of it, okay? And for this amount of time, right? So invested is kind of just a word that means all that. It doesn't mean a specific thing. It just means that your money, this amount of money, is being put into someone else's pockets for a certain amount of time, and you can expect this much. So we just use this formula. The process doesn't really change here, right? That's the future value. So if we try to calculate it, let's see what's going to happen. The future value is equal to the principal, 1,560, plus 1,560 times 0.5%, which will turn into a decimal in a second, and then 18 months. So we do not write 18 here, right? Because it has to be in years. It has to be in years there. So you have to think how many months are in a year. Well, there's 12 months in a year. And so 18 months is a year and a half. So it's 1.5 you'd write there. So it has to be in years here because this percentage is always given in years. Okay, now we have everything we need essentially to type it in, but the last complication is just that we need to be able to write 0.5% as just a decimal, and so that's 0.005 times 1.5, right? And that's everything. There we go. So 1,560 plus 1,560 times 0.005 times 1.5, and we get 1,571.7, right? And so again, you might ask, what's that's the answer for what's the future value. So you've put this amount of money in an account. So we can also ask what the interest gained is in this example, right? So the interest gained is just going to be the future value minus the principal, right? Which is 1,571.7 minus 1,560. So it's just $11.70 in this case, which is, a lot more reasonable. Well, it's still a lot higher than you'd actually get, but in real life, depending on what exactly you're doing. So it's a lot higher than you'd actually get in real life for a savings account, but depending on what exactly you mean by invested, it could mean different. You could potentially get this much. Okay, so there's another example of simple interest. So let's take a look at this example here. Is going to be the last one that's kind of in this format, and then I have two that are, a little bit more to them. So pretty much three examples left here. So this question is, what is the interest gained on $450.45 if it is invested at 50% simple interest? Simple interest for 7 months. Okay, so all I want to include in this question here is that obviously the dollar amounts do not have to have always whole numbers. You can of course have cents, and you usually always round it to 2 decimal places, because when you're talking about money, you don't really care about fractions of cents, right? You only care, the smallest thing you care about is a cent. So you just round to 2 decimal places. And then I just wanted to show what would happen if you had a crazy interest rate. 50% interest rate is unheard of. But let's just see what happens when we calculate things like that. And additionally, 7 months, that's not a nice amount of years, right? So we got to figure out, how do we actually calculate how many years that is? How many years is 7 months? Well, we'll talk about that in a second. So as always, when we're talking about simple interest, we use this formula. This is the formula for simple interest. This is the formula to calculate the future value using simple interest. So the future value of this amount of money is, well, 450.45 plus 450.45, okay, times the annual rate, which is 50%, okay, times the amount of years that have passed. So 7 months is some fraction of a year, right? And you just got to remember that there are 12 months in total in a year, and you have passed 7 of them. So 7 months is 7 over 12 years. Okay, and so that is the number you want to put there. As common to do in financial math, right? 7, you don't really do things perfectly exactly, again, because you really only care about things to 2 decimal places. So feel free to turn fractions into decimals in this unit. It's very commonly done, in fact, almost always. So what's going to happen here is that it's going to be 450.45 times 0.5, right? Because that's 50%, right? Times 0.58, right? 7 over 12 is about 0.58. You can just round to 2 decimal places. And then now we can just add all this together. So 450.45 plus 450.45 times 0.5 times 0.58. Okay, so it is 581.08 is what I got there for that future value amount. Okay, but that's not exactly what the question was asking for. It was asking for the interest gained, right? So it's similar to what I did here, right? Similar to what I did in this situation. We could also calculate it. I wanted to, you already know how to calculate the interest gained using this method. We could also just only take this chunk. That is the interest gain. P times R times T, right? And so that's really just this chunk right here. And so the interest gained, I'll put that here, oops. Interest gained is just going to be that right there, right? Which is going to be, well, minus 450.45, 130, let me just write that here, 130.63. Okay, so that is our interest gain. That is the future value and all that. Okay, great. So let's do two last examples here before we finish off the lesson. So let me write down the question. So you borrow $500, well, let's say $600, at an annual rate of 8.25% simple interest. Okay. Let's just say you borrow it for whatever reason you might want to. You plan to repay the loan in 18 months. Okay, so we got three little parts to this question here. So the first two are pretty similar to what we've done before. So what amount do you have to pay back? So what amount do you have to pay back? Do you pay back? Okay. So to do that, right, you just calculate the future value, like we've been doing, right? The future value is this amount right here. Oops, can I get this here? So the first two parts of this question are very similar. The future value is equal to the principal. The principal is $600 plus 600 times the annual rate, 8.25%, right, times the number of years that have passed. So 18 months, once again, let's make it a little bit more interesting. What if it's 19 months, right? Because you already know what 18 months is 1.5. Let's make it 19 months just to make it a little bit more complicated. So 19 months, again, you just have to remember that to convert from months to years, you just say, well, 1 year has 12 months, so that's the denominator, right? And 19 of those have passed, right? So 19 over 12 is going to be just slightly higher than 1.5. It's 1.58, right? So the future value is going to be 600 plus 600 times 0.0825 times 1.58. Okay, and that's going to be your future value, 600 plus 600 times 0.0825 times 1.58, and we get 678.21. So what that means is that after these 19 months, your the interest, the final value that you have to pay back is $678.21. Then the next part of the question is, what's the interest? What's the actual interest that you have to pay, the extra interest you have to pay here? So the interest is just going to be, your future value minus the principal, right, which is 678.21 minus the principal, which is 600, right, which is simple to see. It's $78.21. So you've paid $78.21 here. Of course, you could also do this by just using the actual formula for the interest, which is PRT, which you'd also get. It's just this separate section here. It's just that right there, and you'd also get $78.21. So there's two ways to do that there. Okay, so that's for part A. That's for part B. Just find the interest, and then for part C is pretty interesting. How long should you wait to pay back the loan if you want to pay no more than $50 in interest, right? Simple interest, obviously, right? So this is interesting. It's kind of a different kind of question than we've had so far. So how long should you wait to pay back the loan if you want to pay no more than $50 in simple interest? So what we're going to do is we're going to kind of go directly to our interest formula here. The interest is PRT, right? P times R times T. And I want this value to be 50, right? Let's see how long I have to wait, like how long I should keep the money for that interest to be 50, right? Because that's from the question. I want to pay no more than $50 in interest, right? So the equation I'm going to get is 50 equals PRT. And now what values do I know here? P, I know the principal, right? The principal is $600. The rate, I also know, 8.25%. T, well, it was 18 months up here, or 19 months up here, but that made me pay $78 in interest. I want to only pay 50. I need to solve for T. T is what I'm solving for here. So what we're going to do is, first of all, just multiply these two numbers together here. So 500 equals 600 times 0.008, sorry, not 0.0825 times T. So 50 equals, let's set that in, 600 times 0.0825. So that's 49.5 t, right? And then I just want to divide both sides by 49.5. And that's going to let me solve for t. So t equals 50 divided by 49.5, and I get 1.01. And now 1.01 what exactly, right? Well, t is always in years, so this is the amount of years that have passed, 1.01 years. We could turn this into months, but since this is not like a very nice division here, it's 1.01. So what's 0.01 of a year? Definitely not a whole month. So you can just leave like this. It's 1.01 years. There we go. Okay, so just barely over 1 year is how long you should wait to pay back the loan if you don't want to pay more than $50 in interest. Well, that's exactly how long you should wait if you want to pay exactly $50 in interest. Pay it back sooner, you'll pay less. You pay less when you pay back sooner because, remember, the interest builds up as time goes by because time has money has a time value. Okay, there we go. So that's that question done, and then we have our last question here, which is, right? So, oops, here. If you, again, borrow $1,400 to buy a very used car. Well, it doesn't have to be very used, but a used car. You repay the loan in 2 years, okay, in the amount of $1,700. Okay, what annual rate of simple interest? Rate of simple interest was charged. Okay, so essentially we know the principal, the future value, and the amount of time that has passed, and we just need to figure out what the interest rate was. So this is a different kind of question because, in almost all situations you're given the interest rate. This question is just there to, on purpose be a little bit tricky just because it's something you're not usually asked for. So the way we do this is, of course, we got to go back to this formula. This is the formula for simple interest. So just plug everything in that right? Almost all the numbers here. Future value is 1,700. Principal is 1,400. Principal is again 1,400. The rate, we don't know that. I'm going to put an R there, right? The rate, we have no idea. And then the time that has passed, I know that's 2. Right? I know that's 2 that has passed. So 1,700 equals 1,400 plus 2,800 R. Just multiply the 2 and the 1,400. And now we can start solving for R. This is just a linear equation where we can solve for R. So subtract 1,400 from both sides here, right? And we just get 300 equals 2,800 R. And then divide both sides by 2,800, right? And we get that R is equal to 300 over 2,800. And the way I like to do this a little bit quickly is because these zeros can cancel, right? So it's 3 over 28, right? Which is 3 over 28 is 0.107. Let's just say 107, there you go. And this is not a percent yet, right? This is just the actual decimal. And then as a percent, that is 10.7%. So that is the interest that he was charged, which is a very high interest to be charged. But anyways, yeah. Okay, and that's the last example I wanted to go through for today. So let's do a little review of everything we talked about, and then we can end it for there. So to begin, let me scroll back up a little bit here in my notes so that I can see what exactly we started with, right? So to begin, we started with the concept of interest, right? Which is something you kind of have to work out in your head, right? And then we looked at the goals of the chapter, and the kind of questions that we're going to be answering in this chapter, which is like, how should interest be calculated? Exactly what is a fair way to do it? What if you make monthly payments, stuff like that? So those are all the things we're going to be answering in this chapter here. Then we talked about the time value of money, which is a very important concept that you're going to have to, always going to be underlying every single thing we talk about in this chapter is that that's true. Okay, and then we went through a couple pieces of terminology, right? Such as principal, right? Future value, rates, and those were I guess interest earned, interest paid. There you go. Okay, and then we defined simple interest and did some examples of that, right? So simple interest is not really very complicated. It's just a pretty simple formula, but it is a good start in trying to understand, pretty much the main idea of this chapter, of this section, I mean, is just to get these concepts, right? To try to understand those, because doing simple interest is not that bad. Like the actual calculations is pretty simple. It's just a formula. But to actually understand what you're doing is the harder part. And so that's why these are the ideas that we spend most of the time on talking about today. Okay, so that is everything for this lesson. I hope it was helpful. So as always, you can email me at secondteacherprogram@gmail.com. Gmail.com. And of course, you can also book a session with me or another instructor by going to the information page for this website. Thank you so much for watching this video. I hope it was helpful. And check out the practice problems for this section, because this is some good things to practice. Probably a lot of them will be conceptual ones, right? Because the actual math of this is not too crazy. Okay, thank you so much for watching. I hope it was helpful, and have a great day. Thank you for watching the video. Remember, if you want me to teach you the entire course, visit my website, tutor.ca, and enroll in the Second Teacher program, which includes video lessons, private tutoring, notes, and practice problems for every section in grade 11 functions. Have a nice day.